So in this session, we are going to present about concepts and components of blockchain technology and analysis of integrating IoT and blockchain technology. Right. So I'm going to share my screen. Yeah. Hope my screen is visible and I'm audible.
Yes, sir. It's visible and also you are audible.
Thank you. Yeah. So in this session, we are going to present about concepts and components of blockchain and analysis of integrating IoT and blockchain. Right. Myself, Dr. K. Senadipati, I'll present about concepts and components of blockchain, and rest of the part will be continued by Dr. D. Surendran, Professor CSC KPR Engineering College. Right. So hope you had have got an idea about what is blockchain technology in the previous session, which was handled by Vairam, Dr. Vairam.
Yes, sir.
Anyhow, I'll start. Anyhow, I'll start with the introduction part, and later on, I will move on to the concept part. So, what is a blockchain technology? So, blockchain technology is nothing but a chain of blocks which contains information about sender, receiver, and the number of bitcoins to be transferred. Each block has data and hash value of the current block and hash value of the previous block. And each block consists of zero or more transactions. Why I'm saying zero or more transactions? The first block of the blockchain is called as Genesis block, which contains the configuration part of the network or configuration about the blockchain network itself. So it does not contain any any transaction details. So that is why it is called as zero or more transactions. So each block contains a data part as well as hash value of the current block and hash value of the previous block. So since it has hash value of the current and previous blocks, it is more secure, or it makes the blockchain technology more secure. And also, since it is distributed and it has a mechanism of a proof of verification or proof of work mechanism, it is very tough for us to tamper the block. Right. So this is a brief introduction about blockchain technology. So what is blockchain? Blockchain is nothing but chain of blocks which contains information about the transactions, right? Sender, receiver, the number of bitcoins to be transferred, and each block contains hash value. Each block hash data as well as hash value of the current block and hash value of the previous block. So it has a hash value, it is more secure, right? So tampering is not possible in case of blockchain technology, right? So that's the introduction part about the blockchain technology, right? So that's about introduction. So let's move on to the various terminologies in blockchain technologies, right? So business networks. So normally, generally, business networks achieve benefits through network connectivity, through connected customers, suppliers, banks, and partners, right? So wealth is generated by the flow of goods and services, and market is nothing but is a central place to this process. Market can be a public market or private market. So these are some of the terminologies used in blockchain technology. And what is meant by an asset? Asset is nothing but anything that is capable of being owned or controlled to produce the value. So that is the basic definition about asset. So there are two types of asset. One is a tangible, and second one is a intangible assets. Intangible assets further divided into financial, intellectual, and digital assets. Right. So cash is also an asset because it has property, it has some value. So cash is also an asset. As far as business is concerned, ledgers are very important, and similarly, as nothing but a book or a computer file which records your financial transactions, right? So, with the debits and credit details, with debits and credit details. So, ledger is the system of record for a business. So, you can have multiple ledgers for multiple business networks, right? So, ledgers are very, very important as far as business is concerned, as far as blockchain is concerned. And the next terminology is participants. So participants are nothing but members in a business network, right? So members in a business network, the member may be a customer, a supplier, or government, or regulator, right? So they are all called as participants. And transaction is nothing but transfer of an asset. Contract is nothing but conditions for the transactions. Conditions for the transactions. So these are all some of the terminologies I'm talking about, right? So what is blockchain? Blockchain is nothing but chain of blocks, or we can put it in a different way, that is shared ledger technology, which allows any participant in the network can have the ledger, can see the ledger, can validate the transaction, can confirm the transaction, can have the copy of the ledger, right? So that is about blockchain, right? So blockchain is nothing but chain of blocks, or I can put it in a different way, that is a shared ledger technology, which allows any participants to the uh, keep keep the copy of the ledger or to see the ledger, right? So that's about blockchain, chain of blocks. Each block contains information about the transaction, right? Each block may have zero or more transactions, right? So why it is zero or more transactions? The first block of the blockchain or the network is Genesis block, right? Which contains the configuration details about the network. So it will not have any, it will not carry, or it will not contain any transaction details. So that is why it is called as zero or more transactions, right? So when you look at this origin of the blockchain, there are some shortcomings and crises in the current transaction systems. In order to provide the solution for this, we are moving on to blockchain technology. So what is the shortcoming and crisis in the current transaction system? I'll explain you with an example. Consider there are two parties, party A and party B, right? So party A wants to transfer some amount or some money to party B, right? In this scenario, both party A and party B should have an account in a bank. Should have an account in a bank. So bank here, bank is a third party. Bank is a third party, right? So party A will initiate the transaction, will send the transaction request to the bank, and what the bank will do is will deduct the amount from the party A and will credit in the party B's account, right? So here there is no physical transfer has happened, but the ledgers of party A and party B are updated. Party A and party B are updated. So if it goes smoothly, if it goes well, no problem at all. But if anything has happened for the ledger, because here the ledger is maintained centrally by the bank. No copy is maintained at party A and party B. Here the ledger is maintained centrally at bank, right? If the ledger is corrupted or the transaction details is changed by the bank official unknowingly or mistakenly or purposefully means, what happens? The trustworthiness of bank gone away. So nobody will trust bank, right? So that is what is happening now. So in order to provide the solution for this, we are moving to the blockchain technology. So here in this blockchain technology, everyone in the network will have the copy of the ledger. So distributed ledger here, and there is no third party is involved, right? So if party A wants to transfer some, wants to do any transaction to party B, they can directly do it. So there is no involvement of third party here. And how the transaction will happen, how it is secure, I'll explain you in the forthcoming slide. The next one is problems of digital currency. So what is digital currency? So digital currency is nothing but the currency in the form of digital or electronic form, but it is not crypted one. It is not crypted one. So anyone can have the copy of it. It's similar like downloading an attachment from email, right? So and it is very difficult for us to distinguish counterfeits, which is original and which is counterfeit, right? So it is very difficult for us to distinguish counterfeit and ownership problem. Who has the original money, original currency, digital currency? So perfect copy. And the second one is double spending. The same currency can be spent more than once. So these two are the problems of digital currency, right? So in order to provide the solution for both, we are moving to blockchain technology. So centralized banking is not robust, and digital currency is not perfect, not reliable. So Santoshi Nakamoto proposed a solution for this, that is Bitcoin and blockchain technology, wherein the ledgers are distributed everywhere or to every participants, and it replaces cash with the ledger. It replaces cash with the ledger, right? So we are moving to Bitcoin era, right? So here, instead of centralization, we have done decentralization, and it replaces cash with the ledger, right? And the participants can have the copy of the ledger, and there are two important blockchains. So one is a public blockchains and second one is a private blockchains. In public blockchain, users are anonymous. Each user has a copy of ledger, and here there is no permission is required in order to uh, participate in the transaction or participate in the network activity, right? So each user can have the copy of the ledger, and for everyone can confirm the transaction independently. But in case of private blockchain network, here users are not anonymous. Here permission is required in order to participate in the activity, in order to participate in the transaction, or in order to participate in the network activity, right? So permission is required, and the permitted people can have the copy of the ledger, and they can participate in the confirming and validating the transactions, right? So here, from the centralization to decentralization, from the cash to ledger, right? So we move from centralization to decentralization, and from cash to ledger, distributed ledger. And blockchain technology is a decentralized ledger or distributed ledger. Right. So whenever a transaction is confirmed or validated, and a block is added into the blockchain, a block is added into the blockchain, and this is the structure of the block. Right. Every block contains information about the sender, the receiver, and the number of coins to be transferred. So which contains a we can say which contains the transaction details, and as well as the hash value of the previous block and the hash value of the current block. So how does a blockchain work? So this is the step-by-step view. Initially, the user requests for a transaction. So that is the first step for the blockchain transaction. The user has to request for the transaction. So whenever a user requests for the transaction, a new block is created, and that is distributed over the network to all the nodes. All the nodes will validate the block, will confirm the transaction, right? And once it is validated, a new block is added into the blockchain or added into the chain. And finally, the transaction gets executed and the transaction gets verified and executed. So this is how the transaction will happen in blockchain, right? So the first step is user has to request for the transaction. So once the uh, request has been given, a block is created and distributed over the network or broadcasted to the network to all the nodes. The nodes which are in the network has to validate the block, and once it is validated, the block will be added and then the transaction will be carried out. So this is how the blockchain will work, right? So this is uh, about the blockchain transaction. So someone requests for the transaction. The requested transaction is validation is carried out, and once the validation is carried out, a new block is added into the existing blockchain, and the transaction get completed. So here there is no involvement of third party. So here we are not involving the central bank or any third party for the transaction, and then there is no physical form of transaction has happened, right? So why blockchain technology? So these are the advantages of blockchain technology. Just a moment. So here no third party is involved, and then unalterable copied only, because here every block has hash value, and hash value of the previous block. So it is unalterable. It's immutable. If you change any data, or if you try to change any value in the block, the hash value of the block is going to be changed. So it is unalterable or immutable, and there is a possibility of real-time tracking, and provided high security and the transaction is trusted one, it reduces the cost, right? So why blockchain technology, and why do we need to get into this blockchain technology? So these are the advantages, right? So it is reliable and unchangeable, unchangeable or unalterable, because every block has hash value. So if you try to change any value in the block, it will automatically change the hash value. So once blocks, the rest of the blocks will be considered as invalid. So it is unalterable, and it provides high security, because even though it is distributed one, it provides a high security. Transparency is maintained, because the ledgers are distributed to everyone. It's similar like a public ledger, right? Everyone can see the ledger, and everyone can have the copy of the ledger. And collaboration, it allows us to collaborate each other, because parties or participants can transact directly without the involvement of the third party. It is decentralized, right? So these are the advantages of blockchain technology. And the next one is, what is cryptocurrency, right? So cryptocurrency is a digital form of the money, but here which uses a cryptographic algorithm, right? So cryptocurrency is digitally generated money or digitally generated currency with cryptographic algorithm. With cryptographic algorithm. So there are over 2000 cryptocurrencies available, Now, presently, there are 2000, more than 2000 cryptocurrencies available, right? For example, Bitcoin, Ripple, right? So these are some of the examples of cryptocurrencies. So, do you think Bitcoin is a blockchain technology? No, Bitcoin is different. Blockchain technology is different. So, Bitcoin is a digital token. So, whoever has the digital token can do the transaction, right? So, Bitcoin is a digital token, and blockchain is a ledger that keeps tracks of who owns the digital token, right? So, Bitcoin is a digital token. So, you cannot have a Bitcoin without blockchain, but you can have a blockchain without Bitcoin, right? So Bitcoin is a digital token. Whoever has the digital token. So blockchain is a ledger, distributed ledger that keeps track of who owns the digital token. And these are the examples for the cryptocurrencies: Ethereum, Bitcoin, Ripple, Litecoin. So there are more than 2000 cryptocurrencies available. So the next one is futures of blockchain. So first one is a decentralized one. It is decentralized because it follows a decentralized mechanism, because transaction must be validated, must be confirmed. So without that, the transaction will security. So every participant will be provided an identification. Without authenticity, no participant will be added into the network and increased capacity. Right. So the size of the network can be increased. So these are the features of blockchain technology. And next one is types of blockchain. There are three types: consortium blockchain, public blockchain, and private blockchain. So consortium blockchain is nothing but a group of organizations will have the access to the network. So that is consortium blockchain. Only the group of organization can participate in the transaction. Will participate in the activities. So that is consortium blockchain. The next one is a public blockchain. It is open to everyone. So public blockchain is nothing but
Participant kindly wait. Some network issues.
Very good morning, dear participants. This is Surendran. Can you hear me?
Yes, sir.
Am I audible, ma'am?
Yes, sir. Audible.
Okay.
Yes. Sir, Surendran, sir.
Yes, madam.
Sir, are you continuing, sir?
Yes, ma'am. Sir has
Uh, yes, sir,
up to
left the
which point he
meeting.
has gone?
Sir, up to that blockchain overall thing, sir. Sir, do you have that
He
slide,
has
sir?
talked about shared ledger, consensus, and virtual machines. Four concepts of
Yes, sir.
blockchain:
On the way, sir. It was
Bitcoin,
on the way, actually. It was not a completely.
building trust.
Yes, sir.
Different players. I should start with different players in implementation, right?
Yes, sir.
Slide number 28. Slide number 28. Yes, ma'am.
actually he was talking about the types of blockchain, sir.
Types of blockchain.
Yes, sir.
Consortium blockchain, public blockchain, and private blockchain.
Yes, sir. Yes, sir.
Right.
Senadipati also
Okay.
joined, sir, now.
Sir,
Senadri sir, will you finish up?
yeah, please.
Yeah, finish up, sir. No worry.
Sorry, professors. There was a network connectivity issue. So these are the four important components of blockchain. The first one is a node application. So any machine who want to participate in the ecosystem have to install this computer application. So node application is nothing but a computer application. And the second one is a shared ledger. So shared ledger is a data structure which is managed inside the node application. And then next one is a consensus algorithm. So this is a logical component of this blockchain technology, which provides the rules of the game. And the last one is a virtual machine. So this is the final logical component of the blockchain ecosystem. It acts as a bucket or container where all the logical components rest, act, and energy. And these are the important concepts of blockchain technology. The first one is a distributed shared ledger. As I mentioned earlier, in this blockchain technology, it follows distributed ledger, or it's a distributed ledger technology, and it applies cryptography in order to maintain the security. It has a hash value. It applies hashing mechanism in order to protect the block value or the information, and it requires consensus from all the nodes in order to confirm the transaction, in order to validate the transaction. And smart contracts this will be dealt by Dr. D. Surendran. He will explain you about what is smart contracts all about. And uh, this is the differences between Bitcoin system and the current banking system. So current banking system follows a centralized mechanism, but Bitcoin system follows
Sir,
a
voice breaking is
decentralized
there, sir.
system
Sir, Senadipati, sir.
the ledgers are distributed over the network to all the nodes. So every node can have the copy of it. And here everyone have the, is it? Hello?
Sir, your
Can you hear
voice,
me?
sir, your voice is
Yeah? Can you
breaking.
hear me?
Sir, it's,
Hello? Can you hear me?
sir, we can
Hello?
hear you, but it's
Hello?
breaking, sir. Your voice is breaking.
Suren sir? Suren sir, can you continue with from this slide?
Yes, sir. I'll take up.
Hello?
Yes,
Yes,
sir.
sir.
I'll take up. Am I audible, ma'am?
Yeah.
Sir, you are audible, sir. Surendra, sir, you are audible, sir.
Yeah, thank you, sir.
Okay. Okay.
Sir, I stopped my presentation. You can present your
Yes, sir.
screen share.
Yes, sir.
Thank you,
Good
Senadipati,
morning.
sir.
Thank you, ma'am.
Okay, sir. Sir, you please continue, sir. Surendra, sir.
Sir, the participants, very good morning.
Good morning, sir.
So I'll start from here. These are the main components of a blockchain. Right. Before going to look into this components of blockchain, as usual, I'll just start with some video. because videos are better than monotonous talking and watching. So I think I have shared few links which I wanted to share with you, right?
Yes, sir.
And that I'll just like try to show you. The last one, this is the link which, so this is blockchain. Let me check up 1 second. So in the meantime, if you have any specific queries, the participants can ask. And meantime, I just wanted to tell you one thing. It's because all these blockchain, etc. So these technologies are now evolving. Evolving in the sense, uh, okay. Like any questions or queries? Swaruprani madam, very good morning. Okay, so this is one pretty good presentation. It's 20 minutes, but still I just wanted to run it. It's a very, very fantastic presentation on blockchain, right? Shall we move it? Shall we move, Kyle ma'am? Shall we see this
Yes,
video,
sir.
ma'am?
Yes, sir. Uh,
Yes, ma'am.
okay, sir.
You get the videos, no ma'am. Audio is visible. Audio is audible, ma'am.
No, sir. We could see only the video. Audio.
Audio is not here.
No, sir.
You don't get the audio, ma'am.
No, sir. We could not hear voice from that video, sir.
Your audio is not visible. Audio is not able to hear.
Yes, sir. We could not hear, sir.
1 second, ma'am. Let me try. Let's stop the presentation. I present from the beginning.
Okay, sir.
Now is it audible, ma'am?
Uh,
Ma'am, is it audible?
no, sir.
No, sir.
Not audible, sir. Not audible. Sir? Hello?
Ma'am, audible? Ma'am, am I audible? Hello, can you
You
hear
are
me, ma'am?
audible, sir. Yes, sir. Sir, you are audible, sir.
1 second, ma'am. Now,
Okay.
can you hear the video, ma'am? Can you hear the audio?
No, sir. Now only it's.
Not able to hear, ma'am?
No, no, sir. No, sir.
It's like, okay. Anyway, I'll just browse through this thing and tell you the key things with this presentation.
Okay, sir.
Here with blockchain, anyway, I've shared this link. You can just later go through. Now, this is the first era that is in the 14th century. That invention, which has radically changed that particular 14th century, is the printing press. Till that particular point, there is no exact way of sharing the knowledge. So that knowledge gap was filled by this printing press. Then, as the second gap is what you mean by the power gap. So this power gap is filled by your what do you say, your engines, IC engines, right? So this is shown here. You can see this now. Participants, you're able to see. Ah, fantastic. Sidhuja ma'am, yes, good. I'll just enable the captions. That's good. Fine. That'll just add thing. Sorry.
Yes, sir.
Yeah. We'll start from here. here, this is where we're talking about a ledger. So the ledger or the Bitcoin, I mean, like what is being told. So here, this information, more specifically trying to understand, it has a key. As you told, it has a key, and nobody can tamper it. Now here is where the cryptography comes in.
Sir, excuse me, sir.
Voice is not audible, ma'am.
Yes, sir.
Now it is clear.
It's now clear, sir.
Okay. Now try to understand. So this is what has been told here is that here we are talking about properties, and these properties we have revenue departments, and that revenue departments stores the details about the properties. Now here it is that the first transaction, second transaction, third transaction. So these are all stored in ledgers. Try to understand. Now when we are talking about a ledger, ledger is anything which holds transactions. Now revenue department, banks, or corporation offices, anything, courts, for that revenue department. Any department which you have a kind of a transaction and storing of data is what you mean by a ledger. So we'll understand that way. Now, here, what is the problem here is that we think ourselves when we were, no, I'll tell you my own case. When I was doing my PG, when I was doing my PG in the year 2002, 2004, I studied in mobile networks about your wallets. At that time, you are not very clear about what you mean by a wallet, right? Now we are using Paytm, Google Pay, etc., etc., right? So they call them as plastic currencies or wallet, right? Everyone are now using it, right? So it's again, it took 10 years, almost a decade for you to understand and to use this paper currency, right? In the same way, blockchain is just now a beginning. It's just now a beginning. And we have a radical penetration of these things that going to happen. So we'll witness in another 10 years, maybe another decade, by 2020 and 2030, maybe 2040, they'll be having to have a major disruptions. I'll tell you what do you mean by the major disruptions here is that here the entire business flow is going to change. Now, a house is sold, a house, how long it does take to get this information? 30% of the titles in your, like, it's like when you are just checking your when you are buying a property, you'll go to check with the encumbrance. You go to tn.reginet.in and give the what do you call, the SF number of the property and you get the transactions. Now here the problem here with the conventional thing is the current ledgers can be tampered. So here we have seen many properties, somebody create fake documents and take ownership of that particular. I'm taking this real estate as one scenario because it's very handy, because almost all the examples which now talk about blockchain will talk about the what do you mean by the concept of kind of real estate, because real estate is very versatile and very common example which everyone can understand, right? So now here is the thing you need to understand. The core part of your blockchain is your cryptography, your cryptography standards. Philosophically, I'll tell you another way. We know, like we know about the one-celled amoeba, right? Now, what happens is that amoeba or starfish, we say, like you cut it into pieces that again joins together. Try to understand this big kind of an example to understand this Bitcoin. I'm sorry, blockchain. Try to understand this as a blockchain. We have seen in movies, right? You'll be having a demon or terror, and you just break it, and it automatically builds up its own again. Yes, you're able to understand. Even if you try to tamper, it's not tamperable. If you think it is tampered, it automatically gets a soft state synchronization and it goes to the previous version. This is the one thing you need to understand. It's a very, very fundamental thing of blockchain. Since we have not used it, since we have not seen it, since we have not witnessed it, we don't get to have a good understanding of this. Right? Is it clear? Now try to understand, like even Paytm, Google Pay, we operate. We know we are sending money from one internet banking. We are sending money from one to another. The transaction gets over. Everything happens. We don't deal with currencies. Something happens behind the scene. In the same way in blockchain, what happens is you have your cryptographic techniques, and these cryptographic techniques, by way, give you this tamper proofness, and by way it gives you a way of not being stored centrally. It will be stored distributed, right? Is it clear? So this is they are not the system is that they are changing. Earlier the title was something, and now that title has been changed. And now here the thing is that now try to understand that we don't have the revenue department, we don't have stamp vendors. The idea is very simple. We don't need banks, we don't need registration departments, we don't need any trusted third party. For that, people of the peers will work together. This is the major thing you need to understand, and you will ask the middleman and middlewoman intermediaries. These are the entities. Now, the problem comes is that when these entities are not consistent and when these entities are not providing the trust that is given. This is the main idea of this thing. Of like, the thing is that we are looking to be trusted. So now these companies are going to vanish. Banks, title companies, credit agencies, right? So these are going to the Department of Motor Vehicle. It's going to go, right? So like RTO departments. Now I'll say a funny thing is that we will not have any codes. I don't know whether it's going to be a reality or not. Right? You're able to understand, participants? Is it clear? Uh, were you all following me? Okay.
Yes, sir.
Okay. Now this is the idea. Like this is where we have been talking about that. When all these things are provided, when the legal regulations are okay, when these techniques are proven to be tamper free, and it is checked the length and breadth of brute force, and it is proven, like as with internet banking, now this will go to a next major revamp of the way, right? So as with these companies will not be needed, right? Now here that we manufacture and don't have any trust, and we have an abundant trust in the other side. Now here is where you need to understand the gap. This particular trust gap is going to be filled by what you mean by the blockchain, right? So here the idea here is that we don't have any intermediates, and here is the thing that is shown. The traditional ledger is now converted into a hyperledger. It's called as a hyperledger, a smart contract, and you don't want a central repository. You don't want it to have a trusted third party. You don't want it to have an intermediary, and you don't want a server to store all these things. Is it okay? So too much of this thing we have been talking concept. Like how come when you just go to realize, right? That is the question, right? Even if I've been a participant of this particular so-called FDP, I'll be asking that, can I see this? Will I be able to see this, right? Do you have the question? This is what you mean by the blockchain. So now here you cannot tamper. Even if you tamper, it rebuilds. Right? For that particular case, I have told you it is a starfish or an amoeba, which automatically gets its shape again as it was. Right? So this is the strength of your thing. Now here is the idea that the same thing is being showed in this particular video. For the property or the real estate, you have the architect, owner, builder, insurance contractor, and the government. All these parties are involved in this particular case. Once this particular thing is being converted into hyperledger or a blockchain enabled thing, all these entities will vanish, and you will have only the seller and the buyer, or the only the proprietors alone. So this is what is. So to achieve this thing, you have something called as the consensus, right? So this will have to happen, right? So here blocks of transactions appears, they get written on top of and appear eventually, and they are distributed, right? It's a distributed immutable ledger. Now people will ask how it is work. Do you have any proof, or do you have any systems that work, right? Right. Is it? Do you have any questions now, participants? Do you have any questions? So, Do you have any questions? Please, I need a help. As I've logged in now, I've lost the previous chat. Can somebody chat? Can somebody copy that particular links and share me here in the chat, please? I've in the previous chat, I have shared few links. Can someone copy it and share it again in the chat here? Kyle, ma'am. Swarup Rani, ma'am. Oh, you do last. Okay, then I'll take it. I'll take it. I have a notepad. Sorry. Yeah, this is here. Okay, I'll just share it again. Paste it here. Okay. Now, like having told about, this is one video which you can see it later. This is one thing. The difference between tamperable and centralized systems and immutable and distributed systems. Trusted, immediately recorded, and easily available. Right. So this is one thing to understand. So all these things are written in a blockchain. Here is that the final thing. Here you have knowledge companies with the printing press, with the IC engines. There is manufacturing companies or motors, which filled the what do you call the power gap, and online companies, the internet, that websites and etc. e-commerce models that has minimized the distance gap, and this Bitcoin is going to like blockchain is going to bridge the trust company or trust gap. It is going to build the trust gap. Now it is okay. Is it clear? Now again, as I told you, it will take another 2 decades or 3 decades, maybe half a century, maybe a quarter century, right? Yes. This is okay.
Yes, sir.
Okay. Now coming to the realization part. Now you'll ask me, like, so far conceptually, everything, video part, everything is okay. How to build a Bitcoin system? Yes. Yeah. As usual, Sarubrani madam is giving a yes. Okay. Now, how many of you have your AWS account, Amazon account? Then it's fine. Have you tried blockchains with Amazon? Fine. The same thing happened with your own. Now I'll show you. This is my AWS. This is my AWS console, and here I have a managed blockchain. Now I'll show you this particular link also. Now, so this is an Amazon managed blockchain. We can easily create and manage scalable blockchain networks. Fine. This is okay. So this is something beyond the theory part, right? Yes or no? So now I'll get you the link for this also. AWS. AWS. Okay. Yeah, now I'll go to managed blockchain. Yeah. Fine. Now here, I'll share this link. Okay, fine. Now, can all of you open this link? You're able to open this link? Okay, for your reference, if you wanted to open. So how it works is this way. Now here you have the Amazon managed network blockchain, Amazon managed blockchain. With that you can create a network. You can choose an open source blockchain framework, set up a new blockchain network, and your membership in your AWS account with just a few clicks. And then you can invite your members or the partners of this particular blockchain. Invite others AWS accounts to join the network. and then you can add nodes. As you say, the hyperledgers are maintained in the nodes. So then you can create and configure the blockchain peer nodes that store a copy of the distributed ledger, and you can deploy your applications. Right? Create and deploy decentralized applications to your network through your peer nodes. Transact with other members of the network. Fine. Is it clear? And I've tried to go this way, and I've created a network. I am yet to join the thing. So here is that. Here is the check. I'll show you the step by step. I have already created one such. I'll show my console. So this is my console. So I have an amazing managed blockchain also. Now here is my blockchain. I've created a service. So it's an Amazon managed blockchain. So I've given a name like Sttp test. This is the network I have created, and then I can create an VPC endpoint, and I can add the members, and then I can create proposals. Right. So with that, I can add members. I can delete the members. It's the part. Right. So here is that you can say. Now here, if I have invited anyone, I can just see the invitations here. So and now this is my network. So this is my communication endpoint network of my Amazon managed blockchain, right? So this is my thing. This is my starting point right now. So it uses the framework Hyperledger Fabric. I've used the Hyperledger endpoint, right? So this is the Hyperledger Fabric order endpoint. It creates a shared Hyperledger Fabric ordering service for each network. All members use the ordering service, so your Hyperledger Fabric application code uses the endpoint to refer to the ordering service when necessary. Right now, here I have set the voting policy. Now, if you have 10 members, the voting policy means any particular transaction it needs to be have a consensus of greater than 50%. And only then that becomes what do you mean by a transaction, and that gets stored in the Hyperledger Fabric, right? Now here, no, for the want of time, sorry, I have not. I just only created the network, but I'm not able to say invite the members and add peer nodes and deploy applications, right? So here is that you can give it a try, right? So the things is that you can use your financial services. So the financial services can reduce the time and cost of cross-boundary asset transfers by using blockchain to directly send payments to other networks in a trusted way. And supply chain manufacturing businesses can use an Amazon blockchain network as a transparent and efficient way to keep track of ownership of goods that move across global supply chain networks, right? So now here is that I've shown you that I'll just browse through the steps. Now here is the first thing, how you can create a blockchain network. Here I can use Hyperledger Fabric, or you can Ethereal. Now Ethereal is not available now. Now it is disabled. Let's say it's been coming soon. Then here you can take the version also, which version of Hyperledger Fabric you wanted to use, and then whether you're going to a standard edition or the starter edition or the standard edition, and you give the network name. So you need to give a name of this particular blockchain network. You need to give the name and the description, and specify the percentage of yes votes required to approve a proposal. Whenever you have a transaction or approval, you wanted to have more than. So now here it is greater than, right, or greater than or equal to. Now here you can set up to 100, right? So any consensus, and then the proposal duration, right? How long this proposals are open for voting in 1 hour increments up to 168 hours. You can just give out 24 hours or 50 hours, and then click next, right? So I'll just give. I've created already, and I'll show you here. You're able to see participants. You're following me.
Yes, sir.
You're following me.
Yes, sir.
Okay, fine. Even myself, I have created an AWS account some 10 years or 15 years back. At times when need, I'll just go. Yesterday when I was thinking of this particular session, I thought of giving try with that, and I've tried it. It's just a matter of seconds. It's just a matter of minutes. I went up to these things. I made to add the members alone, right? I'll show you the steps, right? You can also try with your AWS account, right? Now I'll take the version 1.4 and I say standard, and network name is block 1. Block 1 and description and wording policy are just greater than 60%, and then hours is 25, and just go to next. Then it asks for the member. The first step is you created the network, then you need to create the member. So the create the first member in the blockchain. The members are distinct entities within the network, and each network must have at least one. After you create the member, you can add peer nodes that belong to the member. Like, here, so all these things, as as we were seeing of this particular case. Now this is the node, and this is the shared ledger, and here this particular instance of the virtual machine of mine is going to store this, and the consensus algorithm is also stored, right? So this is pretty good that like you can see how it is seen, right? So exactly like how it is seen here, right? So here, then you can create the first member. After that, identifies the members on the network. Each member name is visible to all the members. I say member. Description is not good. And then certification authority. You need to give the certification authority and the admin password, right? Uh, I'll give it as admin as usual. So it needs 8 characters. Then logging informations. You can just logs are stored. If you want to load the certificate authority log, you can correct it and then go to next. Now, usually one thing that happens is responder 1. I think the member name can be. So this member name should be unique also. The system can have alphanumeric characters and alphanumeric. So it is token, and then it goes to the review and create the third step. The first step you created a network, the second step you created a member. You need to have a minimum first member, and then you're just going to review and create. So the step 1 is blockchain network is done. Now here it says the voting policy greater than 16, the proportion duration is 24 hours. where you can edit. The member option, I created a member option with the member name and admin password. Please take a note of the admin password and then create a network and member. If I give this particular step, then the virtual machine will create a network in it with this particular number and with this particular consensus algorithm. Right? So here it is that all these things are available and the ledger and the nodes we need to create. Later nodes we need to create with the members. The members will be having their own nodes as shown here. Um, right. So the next thing will be you can invite the members and every members will be having their own nodes, right? So that thing, I'll just give this as.
So you're not audible.
Now is it clear?
Excuse me, sir. Yes, sir.
Now it is clear?
Yes, sir.
Yes, sir.
Okay. Now this is the thing to understand that we have then we are going to create a network and the member, and this will take a long time. So depending upon the virtual machine thing. Now we can see the status of creating, right? So once this is done, we have created a managed blockchain network, and any AWS account, other AWS account holder, you can add, and this maintains a node in it, right? I have not tried with inviting members and I have not tried with the node configuration at all. Maybe it will be another like you just tweak on it, you will be able to get it, right? So this we will continue with the discussion when it goes on. So we have already have managed blockchain. I have my console. I'll show my console. Now this is my managed blockchain. I've already created one. This is one thing. After you have created, it shows you this particular network. Now this is available. Now this one is just going to create, right? So this is what is the thing that I have created yesterday, or tried to create yesterday, right? So here is pretty simple as that. We need to know very clearly understand. I mean, now here I can edit. Now here I can just like this is my member ID and the name. This is owned by the members of others will be listed here if I'm going to share this, right? Now you have members. You can invite invitations. You can send invites. Not tried. Going to try. So and you can accept your invitation and you can reject invitations. You can see the details, and as well you can see the settings also. You can the size, the settings of this particular network, how many entities is going to show, right? So this is in brief I've tried yesterday, and that particular blockchain network is available and you can tweak. So I've not given like what do you say, I just have given you a small possibility, a ray of hope to do something hands-on and see how it works, right? Now, now it is audible, ma'am?
Yes, sir. Audible.
Yes,
Okay,
sir.
sorry. Okay, sorry. Then, okay, so let this thing go happens and try to have this particular link which explains about the AWS Amazon managed blockchain, right? Fine. Now we'll resume with the presentation or the session. Now, having shown these 4 key concepts, hope you to understand this is a shared ledger is nothing but it is a node. Cryptography is the technique that maintains the so-called transaction as a block, tamper-proof block. Consensus is, as I told you, that for any transaction we have to set how many people say it is valid, right? And then that becomes a contract. So this contract is showed in the ledger. So these are all the concepts of blockchain. Now Bitcoin and current banking systems, as I told you, right? Here with Bitcoins, you don't need banks. You can directly send Bitcoins and so you can directly receive Bitcoins. Now the bank is eliminated. Then the key business benefits are time savings, cost savings, tighter security, enhanced privacy, improved auditability, and increased operational efficiency. Now here, as I told you, it is consumption based and transactional. Again, I tell you that this thing I studied in my undergraduate when I studied about a distributed system. I studied about consensus algorithm, Byzantine's problems, bully algorithms, election algorithms. Now here, Bitcoin puts them all into the reality. Now it is used as one particular, say, what do you say, one model where it, it is made as an application. Now, this is consumption based and transactional. Now, here the two main pillars of blockchain are cryptographic techniques and distributed consensus algorithms. Now, it is a mixture of these two things. Like cryptographic techniques makes your things tamper proof, and distribution is one thing it eliminates the centralized thing. So you don't want to have a server, you don't want to have your backing up systems, etc., etc. Now here is the point you need to understand very clearly. You will be slightly be having clueless about how this thing happens distributed without having to have a central server. Yes. How many of you participants, how many of you have this particular doubt in your mind? Time and again, you are not interacting. So that time just wanted to come back to the chat window. Yes, Swarupmani ma'am. What idea you get about distributed? How it is done distributed? Any synonymous systems we are using? Okay. Now I'll just put a very simple question to all people. How many of your people have been using your what do you call torrent files? Participants? Maybe I don't know. Yes, Swarup Pranamam, you have been using your torrent, right?
Yes, sir.
The torrent is exactly used here in your blockchain.
Yes, sir.
So you wanted to download a movie, nothing is there, you have a torrent file. Now what are the things that are available in a torrent file is that torrent file stores how many seeds or peers that the file the movie file is with particular user, and if that particular user having that particular movie in the machine has been connected to the internet, you can download it, right? Others you're able to understand what I'm coming to tell?
Yes, sir.
Okay. Now it is where in it even myself when I was studying for first time about your blockchain and distributed, like I was like you say, like as I told you, like we don't have intuitions, right? Like we do have doubts, right, of how it is, how it will be done, how it is done, right? Until or unless we get a clarity on how it works. Yes. So this is the idea. I'll show you that the torrent was the inspiration for blockchain. The torrent was the inspiration for the blockchain, or the distribution nature, not to replace the centralized with the distributed, right? And the thing, even if somebody may put me a clever question, what happens if all the copies are lost? Yes. So if you have 50 peers or 50 seats, if all the 50 seats are gone, how to do with it? Yes. Okay, you don't have to worry, because here, as I told you, is you have a minimum of a node. As I told you, when they're creating this network here, go to this particular network. This particular network, the first member, as I told you, the Genesis thing will be here, and this Genesis thing will be holding all the details about this particular blocks and the transactions of them. You don't have to worry. Even if with the other participants are going to go out of this particular blockchain network, still the system and the transactions will be here. Fine. Now I'll come back and resume to the presentation, and then before that we'll see in another presentation. Now I'll stop here and I'll ask you a question. Can anyone give me another scenario where a blockchain can hold good? You give me some sample scenarios where bitcoins can be used or blockchains can be used. Sorry, banking, real estate, retail. Yeah, these are all good. Can you just name and give me another case study or a scenario where the blockchains can be used? Now we have your courts, right? Legal systems. When we just go for a case, evidences are tampered, right? Evidence for any case, a legal case, a police and law involved. Fantastic. Medical data. Okay. Now, how and which particular context you can apply? Like, do you have any like here? What is the tampering or where you have your genuineness going to be challenged in medical data? Try to understand there are two contexts. What are the two contexts? Is you have a transaction kind of a thing, a good or a thing moves from one party to another party, and or else you will have this particular consensus and transaction. So if you say a vehicle is there, if the vehicle is fit to be run on the road, you want to have your motor RTO, regional transport office, one of the motor vehicle department, which certifies the car to be correct one. Now with other things, what happens is there will be 3 or 4 people of the manufacturer, even the car manufacturer and the car buyer will do this thing. Supposing the same way as that, it is the thing you need to understand. Like the question is that how come we are going to survive without banks? That will be the major question, right? Fine. So this is one thing you need to understand, right? That I told you that particular patients and doctors securely transfer data. Okay. Power plants. Yeah, Nitya ma'am, what's the problem with the power plants? Sensitive data. Okay. Now, to profit from the cheap electricity provided by them and the use of mine bitcoins. Okay. Now, in the code scenario, you're able to understand. You've seen in many movies, right? You will have an evidence, and that evidence will be tampered, right? They will change the evidence. So this is one thing, like where if we make that particular evidence as a blockchain, nobody can tamper it. So you need to do a research on it and to understand. This is from my little knowledge I have understood. Yeah, fantastic. Wherever there is a third party involvement, fine. And third party involvement, and we call so-called trusted third party, and that trusted third party poses a threat of tampering the information, tampering the data, right? So think of in this particular way, and then I'm going to say that blockchain is going to be the game changer. It's going to be the future technology. You have lengths and breadths of potential applications and penetrations of blockchain, unimaginable penetrations of blockchain. So we'll come back to the presentation again, right? So here you can build the trust, and the implementation point, you have user, regulator, developer, network operator, traditional processing platform, traditional data sources, and certificate authority. So Hyperledger is another open source library, or it is one thing, like as I told you, it is an API, and now you don't have to worry about all these things. The API is available and you can use it with Amazon as I showed you. So as with release it, highly complex technology that demonstrates the ability to change way we live our lives and conduct business. Blockchain demands across industry open source collaboration to advance the technology for all. So this is made realized here. So this is an Apache open source license. Increasing demand for permission blockchain. Some users or use cases require validating or non-validating nodes to be controlled, or sometimes just sponsored by select whitelisted organizations. Many network operators want transactors on network to obtain an identity from an issuing authority service of a network, and we need public networks as well as private networks, and for the performance and scalability. Now this is the idea. You have a shared ledger, the code execution environment, ledger data structures, modular consensus, algorithms, modular membership services, etc. Now this is what has been abstracted. This is what has been provided by your AWS as a service. Now you need to have API libraries and GUIs for developing a category of app, specialized extensions, membership policies, gateway operation dashboard. So that it depends. And finally, your applications on top of your IP, right? So here is the thing for the services, the membership services, blockchain services, transaction services, and chain code services. So this is a pretty thing you need to understand. It's the identity, privacy, and auditability of blockchain participants. That's the membership plane. The blockchain or the transactions is the distribution transaction ledger, whereby the ledger is updated by the consensus, which is like that. Coming to the chain code. So the chain code is the smart contracts provide the ability to run business logic against the blockchain. So this is the chain code, and the APIs, SDKs, and command line interface gives us the ability to programmatically control the blockchain network. Now, more and more number of APIs are developed in this particular scape, and that are made open, and making use of that particular APIs will be able to develop your blockchain systems, right? Right. Like if it's been covered in the previous sessions, I'll skip. Have any participant given? I mean, has any resource person chat about this hyperledger? Kyle, man. What's the difference between blockchain and hyperledger? Pretty fantastic. Now, as I told you, now this diagram will give you an example. Like this will give you a clarity, right? So, you are able to understand. So, distribution transaction ledger. Ledger is updated by the consensus. Now, this part of the code or the chain code collectively together is your blockchain. The consensus manager, distributed ledger, this is your blockchain with transactions, and the chain code, it's a secure container. Like now, as I told you to say the other way, it is a process management CPU. Without the processor, you don't have a process management. Without your ledger, you're not going to have your blockchain, right? Am I justified you? So, Rupani ma'am? Yes? Now this slide. So this is the blockchain plane here, and then the transaction plane. The transactions are as a block are maintained in the ledger, and this block and the chain code is what you mean by the blockchain, right? Maybe it's permission related difference, maybe more specifically, but here it is that it is what we say, it is overlapping. So the functionality is overlapping. You cannot strictly delineate between the things, maybe up to my understanding, right? Now like from like what I can do here as speaker. Now here you see the block one is created. We have tried to create an blockchain network with the new with block one, right? I've tried to create. It is created, and the details are available, and you can add by members, and you can start creating your proposals, right? And adding the nodes, I don't know, but you can try it of your own. So you can try it of your own, right? So now this particular session, Kayal ma'am, Kayal
Yes,
madam,
sir. Yes, sir.
ma'am, has any speaker talked about hyperledgers and others basics, ma'am?
Sir, only basics, sir. Yesterday, Vairam talked about that, but she told only the basics of what was hyperledger. That's all, sir.
Okay, now I've like just briefly glimpse about these things because my topic is IoT and blockchain, ma'am. So
Yes, sir.
I'll just directly
Combination.
go to IoT and blockchain, right?
Okay, sir.
So now
Or you can give an overall view about this, and then you can say.
I'll take another 20 minutes maximum, ma'am.
Okay, sir. No problem, sir.
Okay. Now these are all the like I'll just glimpse through the topics and I'll come to the IoT and blockchain briefly. So this is the project. This is the energy project with since 2016 hackathon. Now these are all some demos which you can try. I'll anyway, and just Kyle ma'am, I am to share my first day's presentation. I'll send both these things to you. You can share them across. Now here is that we can see the platform as a service, and then Marbles app, and the enterprise integration, and the smart contracts, right? So here is the thing. They are much similar to a legal document and create terms between two parties. The two parties that are dealing with using smart contracts, the contracts use public ledger for storing purposes. Smart contracts are triggered when condition is met and are completely autonomous. To make sure that they work as intended, they are analyzed and managed by regulators. It is useful in understanding trends and predict market uncertainties. So this is the difference. The permissions with the trusted third parties. You don't want the trusted third parties. It's between the users. As I told you, it is distributed. It is between the users. Now I go to blockchains in IoT, the features of smart connectivity. Now this thing I've explained, like why we need to integrate the blockchain and the IoT. So like very often physical objects are used or maintained by multiple parties. Multiple parties need to agree on acceptable usage. So this we call it as SLA. It's called as a service level agreement. We usually call them as SLAs. When disputes between parties require some record of what occurred in order to resolve disputes, as I told you. So this is where legal trials. An event has happened, and that particular event has a log, and that problem with resolving the conflict with the event log is purely dependent on the log. So physical objects of ours are used as equipment, vehicles, building, transmissions, etc. So the effect of the environment may also factor into agreements between parties. When the objects themselves can report on their status, this can assist in processing agreement between parties. Now is it clear?
Yes, sir.
So yeah, why we need blockchains integrated with IoT? The question is answered. What, like what happens? What's the intended benefit of integrating blockchain and IoT? So enable physical objects, that is shipping, containers, manufacturing parts, to participate in secure blockchain transactions. The thing is that now, assume a case that you have like you're placed an order with Amazon, and that particular item is on way in transit, and now we just go to check with its transit facility. Now what happens, try to understand, the object itself has a way that the object notifies that I'm here. So this is the thing. It enables the objects themselves to participate in secure blockchain transactions. Right? You don't think of this case. Now here, the object is IoT, and it is going from one to another. That is the blockchain. So that is what the intended benefit. And how it is done. So root messages. Now it is based on your WhatsApp platform. Now from root messages, connect devices to blockchain transactions. Devices can send sensor data. Now here. Now try to understand. We'll come back to this particular Amazon here. Now here, instead of having the members, if we say these are IoT devices, And these IoT devices have their peer nodes, and these IoT devices are sending and doing their transactions. It's mere extension. It's mere replacement of physical parties with IoT devices. So that is a blockchain and IoT, right? Is it clear? Now, so devices can send sensor data. The identity of the object as determined by things works with existing devices. Does not require blockchain code to run on devices. It's only the authentication data and authentication to be done. Now here with IBM platform maps the device's data format required by the blockchain contract. The data that comes from the device is taken as a contract. So blockchain contract does not have to know about the type of devices sending data or understand their data format. Still a higher level of hierarchy, you can validate the devices in their contracts also. Right. So the example use cases of where the IoT and blockchain can be effectively integrated is logistics. The data are location, temperature, handling, and carrier data. And the use cases you can track, monitor, and report on container status and location, and optimize packaging and transfer of shipments through shipping lanes. So this is the logistic industry. And coming to the electronic industries, the electricity usage, building state. This is very important. The building stage. You have a bridges, you have your structures, your public amenity systems, the buildings. If every frequently we just go and check for its strength. Now for that particular case, like if we have a building and the building has some sensors, and these sensors, we say, I'll come to the case, we have a building surveyors and other things. We have seen some buildings, government buildings, devastating or collapsing of their own, because it's because the builder and the contractor and the persons who inspects, they can forge, they can give false reports. Now instead, if we have a sensor that is fixed to this particular strength determination of the building or the structure or the public amenity, the device is not going to lie. The device will not say. So now it tends to track and monitor the repeat on the building management systems, water management systems, and water, etc. So coming to the finance department, the items consumed, location visited, and usage of devices. Now enable pay per use models. When now this is pretty good nowadays. That this is the commercial part has been almost be very comfortable with the cloud and the internet. You don't have any problems. But still, with blockchain, you have an added level of immutability and accountability that is going to be recorded all along with together. Now, the next industry is your electronics industry. Now you need to talk about again the location, temperature, inventory, and operational stage. Now here is what a new technique we call it as. It is called as the edge computing. Now here agreements for peer-to-peer appliance, home vehicle. Now we have connected cars, etc. We've been talking about one car communicating with another car. So all these things fall under this particular category. So agreements for peer-to-peer appliance, home, vehicle, interactions, and decisions driven by contracts on a shared ledger. Right. So this is here you have the blockchain with integrated with IoT. Then automotive, like here it is that like if you have an accident, and you have a contract with the garage and the license parties, you don't have to go to the surveyor. You don't have to wait for the surveyor to come to the spot, etc. As and when you have met with an accident, it automatically the car sends the IoT sends the details of the accident to the blockchain or the corresponding the law department or to the what do you say, the insurance department. And when you put when you just give your vehicle to the service for the automobile industry, that is also automatically be stored in the ledger, and the claim is automatically processed. Now here is where it comes that you don't want to have the insurance company surveyor, you don't want to have the garage giving you false quotations for the claim, etc. So this is where is the use case, like where the existing scenario, the current scenario or the traditional scenario can be converted efficiently with IoT and blockchain, right? Yes, ma'am. Is it clear? Participants were clear?
Yes, sir.
Okay. So this is the case. Now, uh, So the assets management, past tracking history, what, how, and the benefits, and then warranty, what benefits and how. And here is that IoT and blockchain. It's reported that 9 out of every 10 firms that have already implemented IoT standards are likely to face security breaches in the year. So the blockchain distributed ledger technology can go a long way in refining IoT, cutting out key performance issues, and ensuring security. So the three benefits is building the trust, reduce the cost, and accelerate transactions. Technology whereby mainly security comes into the picture in an IoT context where is a challenge. It is clear that the security needs to be even low. Now here the blockchain can help overcome the potential threats. Then you again, as I told you, the challenge is legal and compliance issues. Like here is why blockchain is a game changer for IoT is that leveraging blockchain for your IoT data offers many way of automated businesses and setting up of complex and expensive infrastructures, right? So here, blockchain data protection gives you your be free of all these things, your operational costs, building costs, etc. So stronger working relationship with your partners, greater efficiency, enable IoT devices to participate in blockchain transactions. As I told you, like here, the traditional blockchain is this is party one and party two. Now instead of party one and party two, have a device one and device two, and you have your policies and ledger policies, and that the devices automatically take part of your smart contract. Then reimagine the world's most fundamental business interactions, open the door to invent new styles of interactions, reduce the cost and complexity of operating sustaining business. Now here all the transactions, I mean the models, we have a field and an asset, and you have a cloud, and you have a blockchain. Now with this particular case, this is a WAN, so this is the field and this is the backend. So this is the technology part. So this is the IoT part. Then this is also a part of the part. Now asset layer, it's like a truck, train, machine. It includes local and remote communication and processing. So on asset or fog, we call them edge or fog. Then you have the IoT cloud. The IoT cloud is asset connectivity and data transmission to the cloud over the air. So we call them as over the air (OTA). Then asset related data and event management, enterprise application interaction. Now all these data are given to the third, fourth, fifth layer. Asset related ledger entities. Now these details in this asset and peer-to-peer middleware for management of blockchains, network of compute nodes for BC. So this is the typical interaction. Now in addition, now here this happens to be a traditional blockchains with participants. Now these participants are going to be added with IoT sensors and devices, right? Now these are the YouTube links. You can just like I'll just open it. Or I'll just leave you to open it offline, right? Right. Okay. 1 second. Let me open my presentation. 1 second. Sorry. Close my presentation. Sorry. So that's only few slides, few more slides to finish my session. Right. So IoT depends on a centralized server. It's going to be for identification, authentication, and data transfer. It's just like, again the same thing. We say that centralized is going to be problematic. The blockchain, we are making it as a blockchain. Like it eliminates the need of central service. Instead, data resides in all nodes of the distributed trustless network, ensuring smooth and autonomous operations. So this is the data-driven IoT system. Now here, data collection and transmission, and the data ingestion, storage, and processing plane, and data visualization and analytic planes. So it's about making business based on the data collected by the smart devices. Right? As I told you, the first interaction is asset, IoT cloud, and blockchain. The second interaction is between asset, the gateway or the fog, and through the IoT cloud using blockchain and the blockchain. And the third interaction is asset, gateway by fog, and then blockchain, and then or the asset directly to the blockchain. So the detail about this thing is available in this particular link. We'll just go through. So, making smart devices smarter, right? So, IBM and Samsung collaborated to launch the decentralized Adept platform, which is your automated decentralized peer-to-peer telemetry platform. It's in 2015. It was tested on a connected washing machine. As I told you, like whenever you have a device where the fault in a device, you need to call the call center, and the call center people send a representative and do this thing. Certain lower level of configuration things can be done with the remote way. So it was able to track the usage of returns, place orders, and make Bitcoins payments for all returns all its own. This is how blockchain technology can make IoT-powered smart devices well and truly autonomous with robust self-maintenance and mobile-to-mobile community and peer-to-peer transaction capabilities. So, can we enhance the security of home IP camera system using blockchain? So, this is one thing, right? So, the greater assurance and trustless messaging and smart contracts. Now, this is where is a brief introduction about the blockchain and IoT integration, the possibilities. There is nothing, what do you say, rocket science with integrating IoT and blockchain. So the traditional blockchain where you have parties or the agents or the players, instead of the agents or the players, you now it has been replaced with the IoT devices or the edge devices, right? So with this, the second chance, I just like thank everyone, the organizers and the participants for making this particular session. And I just like dedicated to all my teachers this particular session. And now it's open for the queries. Any
Participants,
queries, ma'am?
if you have any queries, kindly post it in the chat box or you may ask.
Now, this is another video which is blockchain Internet of Things. In another scenario, it will be explained with. I'll share also in the block window. I mean, chat window. Okay. Thank you, ma'am. Swarupdani, ma'am. So this is what a facilitator can do. I'll not call myself as a teacher. I'll call it as a facilitator,
Yes,
right?
sir.
The major problem with understanding any technology is about our understanding is that how we make things, pictures clear. So that is why I told you with abstraction, anything is possible. When you have a real thing, when you have a real entity, when you have a real scenario, everything can be converted as a technology. This is what you mean by abstraction. Now the physical bank will be replaced with Bitcoins. You don't want the physical bank.
Yes, sir.
Any doubts, ma'am? Any queries or any in general?
Hello, good morning, sir.
Yes, Anurag, sir. Good morning.
Yes, sir. Actually, I wanted to know what is the M2M application? That is machine to machine application.
Which part?
M2M
Yeah, as I
application.
do, all sir, all these things we have been discussing about is your M2M, no? Device to device.
Okay, okay. Device to device.
Yeah.
Okay.
Any possibility, as I told you, with
Yeah.
traditional blockchain, we have parties doing the transactions, right? Contracts, transactions. Now we are replacing, like instead of the parties, we have the sensors or the IoT devices. Okay, sir.
Yes, sir. Thank you, sir. Thank you. Thank you.
Thank you. Thank you.
Sir, really thank you, sir, Surendran, sir. Actually, that day also you helped us a lot. Today you gave a lot of information to us regarding blockchain and also how to integrate IoT with blockchain.
Yeah, okay, ma'am. I'm not convinced. I should have shown you the node creation also, but I'll give me some
Yes,
time.
sir.
You can just give it a try. I've created only a network, a hyperledger fabric network. I need to add members and show you the node. Only then it will be clear. Okay. Sorry, I was also held up with some other work. I was not able to give my fullest thing.
Okay, sir. If time permits, some other day you join us.
Sure, sure, ma'am. Sure, ma'am.
Okay, sir. Nitya, ma'am.
Yes, ma'am. Thank you, sir. It was really a valuable session for all of us. Your
Sure, ma'am.
most valuable talk on blockchain and IoT will be very effective for every participant and the research winners. We are sure all the participants would have attained a good knowledge on types of blockchain, key features, working process of blockchain, core components of blockchain, IoT and blockchain challenges to solve, etc. Once again, we thank you for your valuable input given, which will certainly improve our ideas on blockchain and IoT. Thank you, sir.
Thank you very much, ma'am. I thank the organizers and every participant and wish them good luck.
Thank you, sir. Participant kindly join the afternoon session by 1:45 p.m. with same link. Thank you all.
Sir, Senadipati sir was about to tell something. Senadipati sir.
Yes, sir.
Uh, uh, Thank you, Suryan sir, for continuing from where I left, and thank you, organizers,
It's a pleasure.
for
Thank you, ma'am.
inviting me as a lecture to provide a session. So thank you all. Thank you.
Thank you, sir.
Thank
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 you
you, ma'am.
both Sttp sir and Surendran sir. Participants, that is afternoon's resource person, she will be ready at 1:45 p.m. So we will have the next session at 1:45 p.m. Thank you all. Thank you, sir. Surendran sir, thank you, sir.
Thank you, ma'am. Thank you, ma'am.
Thank you.